In the last video, again, sorry, these are for August 17th and 18th. We're talking about tangent and cotangent. Now, in the last video, at the end, we saw that here we can redefine tangent and let that be just sine divided by cosine or sine over cosine. That's really helpful because instead of dealing with opposite over adjacent, where we have to draw a triangle every time, we can use our unit circle to find sine and cosine, divide those two values, simplify, and that's going to give us tangent. So let's go through an example. Probably do these two, definitely this one, maybe that one, and then talk about tangent pi over 2. But if we wanted to find tangent pi over 4, then what we could do again, sine divided by cosine, or we can write like we did here, which is what I'm going to do. I'm going to write sine of pi over 4 divided by cosine of pi over 4, because that's the angle that we're given here. I'm going to do this as well. Now we can look on our unit circle. Again, if you don't have the unit circle in front of you, that might be a really good thing to have because I'm going to reference it a lot. But if we look at the unit circle, pi over 4, that's going to be in our first quadrant. We can find the sine value is square root of 2 over 2. The cosine value is also square root of 2 over 2. Again, in order to divide fractions, this first fraction stays the same, and then we multiply by the reciprocal. So we flip this fraction and multiply. Now we can keep, I want to keep going because I do want to mention some algebraic properties here. If we have square root of 2 times 2, that's just going to be 2 square root of 2. Now if it were square root of 2 times the square root of 3, or something similar, if they're both under the square root, then we can keep the square root and multiply what's under, so it would be square root of 6. But here, this does not become square root of 4. It merely just becomes 2 square root of 2. Similar thing in our denominator, because we multiply straight across. Now we have something divided by itself, which is just going to give us 1. So in total, tangent of pi over 4 is 1. Again, really helpful because now we can do sine divided by cosine. We found sine of pi over 4. We found cosine of pi over 4. Divide those two values and ultimately simplify as far as we can. Do again for tangent of 7 pi over 6. So if you want to pause, try it on your own. I would highly recommend it, but I'm going to still go through it just in case we're needing some extra help here. So sine of pi over 6, if I look at the unit circle, that's going to be negative 1/2. I'm dividing by cosine of 7 pi over 6, which is negative square root of 3 over 2. I'm going to multiply by the reciprocal. Some students got caught up on the negative. It doesn't really matter where the negative goes here as long as we don't put it to the 2 and the square root of 3. So I'm just going to put it in front. And notice we have a negative times a negative. Ultimately, we're going to get a positive value. So I'm going to ignore the negatives because a negative times a negative is a positive. 1 times 2 is going to give us 2. 2 times square root of 3 is 2 square root of 3 because I'm multiplying the denominators. And here, what some people noticed is we have a 2 divide, like these 2's, they do divide out. We can cancel these 2's out. However, we need to be careful and notice where the square root of 3 is. It's in our denominator. So it needs to stay in our denominator. It doesn't just become square root of 3. That's not what this becomes. Square root of 3 has to stay in our denominator. And that means we have 1 in our numerator because 2 divided by 2 would just give us 1. And like we talked about in, I can't remember if it was last class or the class before, mathematicians decided a long time ago that square roots in the denominator, no bueno. So we're going to rationalize, and make a side note, this is called rationalizing. Rationalize by multiplying top and bottom by that square root. So 1 times square root of 3 would give us square root of 3. The square root of 3 times the square root of 3 really becomes square root of 9, which is just 3. So you might think at the beginning that it takes a little time, but as you do work through more problems, you'll get used to it, and it's not that bad. If you need to pause, rewind, please feel free to do so. Now, tangent of pi over 2, I'm just going to talk about this quickly. So if we do sine of pi over 2, if I look, sine at pi over 2 is going to be 1 divided by cosine at pi over 2, which is just 0. Now in class, I pulled out the phone, asked Siri. If you have an iPhone, ask Siri like 14 divided by 0 and see what she says. But or him if you have it, however the heck you have it set up. But if we divide by 0, we can't divide by 0. So this is what we call undefined. Again, we cannot divide by 0. This is a big no-no. So this would become undefined. Now, we can divide things by 0 by things. So for example, if I do tangent of pi, then sine of pi would be 0, cosine is negative 1. That, in fact, is 0. But here, because 0 is in our numerator, but if we divide by 0, like here, then that would become undefined. All right, let's talk about cotangent, and then I'll show a few more examples and reveal the solution to that next page in case you want to do that. All right, tangent. So let's start with tangent. So if we have tangent of an angle theta, that's going to be opposite over adjacent. Then cotangent is the reciprocal. If you had Mr. Kozak last year, he told you that it was the inverse, and he's a filthy liar. It's the reciprocal, not the inverse, which means that if we're taking the reciprocal of this, then that would become adjacent over opposite. Now again, if we have adjacent over opposite, that means we have to draw triangles every time, which isn't fun. And what we talked about in class, and what some students noticed is, well, hey, we said that tangent of any angle, that's going to be sine over cosine. That's going to be our easiest method to calculate tangent. And if cotangent is the reciprocal, and they said, well, then it should make sense that cotangent is cosine over sine. So if I have this, take the reciprocal, that would just be cosine over sine. And that is true. We could prove it similar to what we did here. I'm not going to do that. If you want to try that on your own, please feel free to do so. It's a really good exercise just to see how fractions work, things like that, and notice that cotangent is cosine over sine. But this we will use. We will use to actually evaluate cotangent, because we have cosine on our unit circle. We have sine on our unit circle, so we don't need anything else, just our unit circle. These two definitions are huge, hugely important, and we will use those throughout not only this unit, but definitely the semester as well. Now, if you need to pause, rewind, please feel free to do so. In the next video, we'll go through some problems, and I'll reveal the other solutions in case you want to check your work to make sure you're doing it correctly.